All right, hopefully you were able to do 3 pi over 4. Our two answers for that one. You should get out 11 pi over 4. Let me make sure I write that the right way. And negative 5 pi over 4. Because what you're going to be adding is 8 pi over 4. All right, so let's talk about reference angles. So what is a reference angle? A reference angle is the distance to the x-axis. Because it's a distance measure, it is always going to be positive, okay? And now the tricky part is to figure out, okay, which x-axis am I closest to? Am I trying to get to 0 degrees or 360 degrees, or am I trying to get over here to 180 degrees? So you just have to figure out, okay, if it's in quadrant 2 or 3, I'm trying to figure out the distance to 180 degrees. If it's in quadrants 1 or 4, I'm trying to figure out the distance to either 0 or 360. So in our first example, we have 222 degrees. So that's down here in quadrant 3. So I'm trying to figure out how far away am I from the x-axis? Well, I can just do 222 minus 180 degrees. My reference angle is 42 degrees. For letter B, I'm at 168 degrees, so I'm up here, right? I'm not that far away from my x-axis. I'm not that far away from 180 degrees. I'm just 12 degrees away. And then 312, I'm down here in quadrant 4, and I'm trying to get back up to the x-axis, but now I'm on the right side of our coordinate plane. So I'm thinking, okay, how far away is 360 degrees? It's just 48 degrees away. And reference angles can be really helpful because you'll notice they're always going to be small numbers. They're always going to be between 0 and 90. And if you can kind of figure out, all right, what is just my reference angle? I can kind of do everything just based off of my reference angle. It makes things a little bit easier. So this is just another one of those vocab words to try to remember from last year, and then we'll maybe use throughout the semester this year. All right, converting to radians. I believe this is in one of our very first sections of trigonometry. So this is definitely a good one to review. Remember, we've got two unit ratios to really think about. We've got pi is equal to 180 and 2 pi is equal to 360. So when I convert, I really want to use this unit relationship right here, that pi is equal to 180 degrees. So if I am given a number in 200 in degrees, that's 260 degrees, I multiply by pi over 180. Because remember, this is really just the number 1. It's just one is in radians and another one is in degrees, but it really just represents the number 1. So that's why I'm allowed to multiply by the number 1. Here's where I recommend that you pick up your calculator, because what you're trying to do is you're trying to simplify the fraction, right? 260 over 180. I'm just trying to simplify that fraction down. So if you do 260 divided by 180, math enter, enter, so you don't have to kind of simplify the fraction yourself, it simplifies down to 13 pi over 9. Whereas when you're converting from radians to degrees, I'm just going to multiply by this reciprocal here. I'm going to multiply by 180 over pi. My pi's cancel out, so I just wind up with negative 4 times 180 divided by 5, and when I do that, I get out, let me pick up my calculator here, negative 144 degrees. So now that we did those two examples, try 12 and 13 on your own and pause it, because I'm going to move on and kind of give you the answers right away. You get negative 5 pi over 18 and 480 degrees. All right, 14 and 15 are definitely the most challenging questions on this worksheet. We're going to do 14 together, and then I'm going to encourage you to try 15 on your own, and we might even go over it together in class when I get back together. So a couple things to remember. All students take classes, if we kind of remember this. This tells me that in quadrant 1, all of cosine, sine, and tangent are positive. In quadrant 2, only sine is positive. In quadrant 3, only tangent is positive. And in quadrant 4, cosine is the one that's positive. So what I do is I'm trying to basically figure out all the different trig identities based on this coordinate point here. So let's draw a coordinate plane. Now I'm going to be at 10, -4, so I really only care about quadrant 4. So I'm going to do 10, -4. So that's this coordinate point right here. I then connect that point as best as I can to the origin, okay? The distance between the x-axis and that line segment that I just drew, that is my theta. That is my reference angle. That is the angle that everything is going to be based off of. And because I know it's trig, I need a right triangle somewhere, I'm going to finish this out by drawing the right triangle. So here, this distance is 10, and this distance, and I keep it negative because it's going to help me to remember, right, what things are supposed to be positive and negative. I'm going to make that -4. So here I've got a right triangle. I've got two sides labeled, but I do not know what my hypotenuse is. So I have to figure out what is my hypotenuse by doing the Pythagorean theorem. So I get c squared equals 116. So c equals the square root of 116. I'm sure there's a perfect square that goes in there. 4 times 29. Of course, I can't pick ones that have nice round numbers. So I get 2 square root of 29. So that is my hypotenuse down there. So now that I've got all these labeled, I've got my theta over here. So I know that this is my adjacent side. This is my opposite side. This is my hypotenuse. I can start to evaluate all the different trig functions. So the sine, that's going to be opposite over hypotenuse. So I get -4 over 2 square root of 29. Those are going to cancel down, so that's -2, but I still have a square root in my denominator, so I have to multiply by the square root of 29 over the square root of 29. But I get -2 square root of 29 over 29, and in this quadrant, only cosine is positive, so that checks out that sine is negative. That's what I would have expected. The cosine, well, that's going to be adjacent over hypotenuse, so 10 over 2 square root of 29. Those cancel, but unfortunately, I still have a radical in that denominator, so I got to multiply by the square root of 29 over the square root of 29. So I get 5 square root of 29 over 29. Yep, cosine is positive, what we would have expected. And then my tangent of theta, opposite over adjacent. And yes, tangent is also negative in that quadrant. So really, I encourage you to draw this picture, plot the coordinate point, connect it to the origin, and then whatever the angle is between that line segment and the x-axis, that becomes your theta. That becomes your reference angle. So go ahead and try 15 on your own. Like I said, we can probably go over this together as a class when I get back. I will warn you, you have another ugly hypotenuse angle value. The hypotenuse in this case, you should get out 2 times the square root of 21. So just a little hint, if that's what you wind up with, then you're on the right track, okay? All right, now the next few questions really have us using our unit circle. And on my Google Classroom page, I've linked the unit circle game. That's a really nice way to kind of practice your understanding of the unit circle, as well as the major angles 0, 30, 45, 60, and 90, a Quizlet that I created. I would encourage you to kind of play with those, remember those, memorize those as much as you can. The sooner you memorize your unit circle, the easier life will be. I promise you that. So let's go through, and we're going to be using our unit circle here to find these exact values. So when you see the word exact, that means you cannot use decimals. You've got to be giving me answers that have the square root of 3 or the square root of 2 or whatever the case may be. You can check these on your calculator, but remember, your calculator, if it winds up being the square root of 3 over 2, your calculator won't tell you that. It will be, 0.8666, whatever the case may be. So the tangent of 150 degrees. So let's remember our unit circle here. We've got our angles in both degrees and radians, and then we have these coordinate points. And the coordinate points represent cosine, sine. Just like x and y, right? X and y are in alphabetical order. Cosine and sine are also in alphabetical order. Now, what we don't have on our unit circle is tangent. Tangent of theta is going to be sine divided by cosine. So sometimes you will have to do some fraction math. Sometimes you will have to find a coterminal angle. It all just depends on the question itself. So the tangent of 150 degrees. So I find 150 degrees and I say, okay, I have to do 1/2 the sine, right? The sine of 150 divided by the cosine of 150. That's how I'm going to get the tangent of 150. So I do 1/2 divided by negative square root of 3 over 2. 1/2 times negative 2 over square root of 3. So I get negative 1 over the square root of 3. And just like all of the examples I seem to be picking today, we have to get rid of that radical in the denominator. So the tangent of 150 degrees, the official answer that we're going to want is negative the square root of 3 over whole number 3. Now our next question is the sine of negative 330 degrees. Negative 330 degrees is not on here. So what I want to do is I want to find a coterminal angle with negative 330 degrees. I'm going to add 360 to this. So when I do that, I wind up with the sine of 30 degrees. And thankfully, 30 degrees is right on here. So I look at 30 degrees, and I look at the sine value, which is 1/2. All right, over here, same thing. Negative 5 pi over 3 is not on my unit circle, but if I find a coterminal angle, I'm going to add 2 pi, which I'm going to rewrite 2 pi as 6 pi over 3. I want the sine of pi over 3. Pi over 3, here it is, the sine value, square root of 3 over 2. Go ahead and move this over so we can see the next question. Cosine of 11 pi over 6, so 11 pi over 6, here it is, cosine is square root of 3 over 2. Move this back over here. The tangent of 180 degrees, so here's 180, right over here, and I'm going to do sine divided by cosine. 0 divided by negative 1. That's 0. Next example, we have the cosine of negative 120 degrees. I'm going to add 360. So what I really want to find is the cosine of 240 degrees. So I find 240, the cosine, which is the x-coordinate, negative 1/2. Sine of negative pi over 2. So if you don't like finding these coterminal angles, you can kind of count in your head, especially when it's negative pi over 2. That's just negative 90. So I'm trying to find down here the sine of negative pi over 2, which is the same as positive 3 pi over 2. So I get negative 1. And then last but not least, the tangent of 5 pi over 6. Well, here's 5 pi over 6, and I'm pretty sure we already did 150 degrees at the beginning, so I already found the tangent of this. 5 pi over 6 is the same as 150 degrees. It's just negative square root of 3 over 3. So that's why I encourage you to practice that Quizlet. If you've got that Quizlet memorized and you can kind of remember the tangent of 30, 45, and 60, it'll really help you out a lot that you won't have to be doing all of this fraction math in your head over and over. Like I said, there's our unit circle. We will be using it quite a lot this year. All right, the second part of being able to use the unit circle is what if I give you a cosine value or a sine value or a tangent value, you have to tell me what is the angle that it relates to. And there are some restrictions here. Because you'll notice, like, what if I say, which angle has a sine of negative 1/2? Well, is it this angle down here, or is it this angle over here, right? There can only be one answer, and so we've come up with these restrictions, And really it relates to the graph of the sine and the cosine functions, which we'll look at in our next sections here. So if I ask you about cosine, the answer is going to be in either quadrants 1 or 2. If I ask you about sine or tangent, the answer is going to be in 1 or 4. Okay? So let's look at our first example. We want the angle that has a cosine value of 1. Well, we want a cosine value of 1, so we want the x-coordinate to be 1. There it is. So the answer is just 0 degrees or 0 radians, because it asks to give you them both answer choices. The next one, we want the tangent of whatever angle has the tangent of the square root of 3. Well, before we were looking at 150, which has a reference angle of 30 over here, and that was the square root of 3 over 3. So the tangent value of square root of 3 comes up over here at 60 degrees, or pi over 3. And you can always double check on your calculator. We want an angle where the sine value is negative square root of 2 over 2. Sine negative square root here, okay? So when you look at your unit circle, you're thinking, oh, it must be just 315 degrees, right? Or 7 pi over 4. Well, unfortunately, these restrictions that are in blue here say it has to be somewhere between negative 90 degrees and positive 90 degrees. So it's not 315, it's negative 45 degrees, and it's negative pi over 4 radians. And like I said, if you want to check on your calculator for these answers, just make sure you're in the right mode, and it's going to be second sine, second cosine. Our last one here, we want to know what angle has a cosine value of negative square root of 3 over 2. Well, here it is right here. So it's 150 degrees, or 5 pi over 6. And for cosine, the restriction, that's going to go from 0 up to 180 degrees. So we're good. We're within that range there. All right, the very last section is graphing, is being able to find the period, the amplitude, and the range for these trig values. And so say I have a function here, cosine of bx plus c. The b value here, that's going to help me with figuring out my period. How long does it take for the function to restart itself over again? The a value represents my amplitude, and a combination of an a value and c value helps me to figure out my range. So hopefully, this will all make sense if we do a couple of examples. So if I want to figure out the period of a function, I take our standard period for cosine and sine, which is 2 pi, and I divide by the value that's in front of the x. Okay, so let's look at our first example. I have cosine of pi over 4 times x. So I want to figure out the period value, meaning how long does it take before it starts itself up again? Because remember, these functions are periodic. They cycle through over and over and over again. So I get 2 pi divided by pi over 4. So I get 2 pi divided by pi over 4. Might make it easier to write it out this way. Then I get 2 pi times 4 over pi, right? I've got to multiply by the reciprocal. So I get out that the period value for this function is 8. My amplitude is just the value out in front. So what's the number in front of the cosine? 1. And then my range value, well, I'm not adding or subtracting anything at the end here. So my range is just going to go from -1 up to +1. Or if you'd rather write it in this notation, whatever makes the most sense to you, my range is going to go from -1 to 1 on the y-axis. And I encourage you to jump over to Desmos and check yourself. Check these answers. So if I'm looking at the cosine of pi over 4 times x, So it starts up here. Let me zoom out a little bit. It starts up here, right? And then it goes down and it goes up. So the period value, when does it go back to where it started from? Well, it does. It took me 8 units to get over there. My amplitude, which is basically the distance from my x-axis, is 1. And then my range value, it goes from -1 on the y-axis up to +1 on the y-axis. Let's go ahead and try our second example here. So my period value, I do 2 pi divided by the number in front of the x, which is 2. So it's only going to take pi for this sine curve to start all over again. My amplitude, well, that's going to be 10. It's just the distance from the x-axis that this function is going to get, the number in front. And then my range value, I'm not adding or subtracting anything at the end, so I don't have to worry about this. In fact, I don't have to worry about that with any of these functions. So my range goes from -10 up to +10. So go ahead and jump over to Desmos, and I'm going to remove that one and put this one in. Whew, okay, that one's a little bit bigger. Let's zoom out a little bit. So here we can see our sine curve goes up, goes down, then comes back up, and it seems to restart right here. Now the problem is my x-axis right now isn't in radians. So I'm going to click on this wrench here, and I'm going to change my step value so I can see everything a little. I'm just going to type in pi for pi divided by 2. So that I can see, okay, my sine curve, it starts right here at 0, 0, goes up, goes down, goes back up, and then yes, at pi, it starts itself all over again. So that's what the period is. How long does it take to complete a full cycle of the sine curve? And yep, we go from -10 up to +10 on our y-axis, so that confirms that our range and our amplitude are correct. Go ahead, try 30 and 31 on your own. And I will fill out these answers for you. So our period for this one is going to be 2 pi over 5. Our amplitude is going to be equal to 2. And our range is going to be from -2 to +2. Our last example here, our period is going to be 2 pi divided by 1/3 pi. That ends up being just whole number 6. So you're going to want the step function on your Desmos there on the x-axis to just be in regular ones, not in pi's. Your amplitude is 1/2, and your range goes from -1/2 to +1/2. All right, goodness, that was a lot of information, especially on a day that I'm not there. Thank you guys so much for your time. There is no homework. I really just wanted kind of you guys to take some time to think about this, hopefully refresh your mind with some of this stuff and get ready for the semester ahead. Next time we will be map testing, so those of you who are juniors, please make sure that you bring your device ready to take a map test. I'm sorry about that. For you juniors, this is your last map test, so just celebrate that it is the last time you will be doing this. For you seniors, I just have to keep both trigonometry classes on the same kind of cycle, that we're all kind of at the same pace, so you just have a free day. So just bring something to do for class next time. Anyways, take care. See you later. Bye-bye.